Look up at the Milky Way and you are looking at a lie. That soft river of light hides something it will never show you. Right now, this second, you are falling around it. A hole in space 4 million times heavier than the sun, sitting 26,000 light years away, and you have been circling it your entire life. By the end of this video, you will see the one photograph that finally caught the monster in the act. For most of human history, the center of the galaxy was just a brighter smudge of stars. We could not see through the dust. We did not know what lived there. Then we built telescopes that see in infrared and radio wavelengths that slip straight through the clouds, and we pointed them at a tiny patch of sky in the constellation Sagittarius. What we found made no sense at first. A faint radio source, almost a pinpoint, packed into a region smaller than our solar system. Astronomers gave it a strange name, Sagittarius A star, and then they watched it for 26 years. This is the part that changed everything. They did not photograph the black hole. They photographed the stars around it. Over decades, telescopes tracked individual stars near the galactic center, and those stars were not drifting. They were orbiting, whipping around an invisible point at staggering speeds. One star, called S2, comes screaming in once every 16 years. At its closest pass, it moves at almost 3% of the speed of light, fast enough to cross the Earth in under a second. Nothing visible sits at the center of its orbit, and yet something is holding it on a leash. Do the math on that orbit and the answer is brutal. To swing a star that fast, the object at the focus must hold the mass of 4 million suns, crushed into a space smaller than Mercury's path around our own star. There is only one thing in all of physics that can do that: a supermassive black hole. For years, that was the proof. Motion, not a picture. We knew the monster was there because of how it moved the things around it. The way you know wind exists by watching trees bend. But astronomers wanted to see it directly. The problem was scale. Imagine trying to photograph a single donut sitting on the moon. That is roughly the resolution you need to image Sagittarius A star from Earth. No single telescope could ever do it, so they built one the size of the planet. Radio dishes scattered across the globe, from Hawaii to Spain to the South Pole, were linked together and aimed at the same target on the same nights. Synchronized by atomic clocks, they behaved as one virtual instrument as wide as the Earth itself. They called it the Event Horizon Telescope. In 2022, they released the result: a blurred ring of fire wrapped around a circle of perfect darkness. That dark center is the shadow of the event horizon, the boundary beyond which not even light can escape. For the first time in history, humanity looked directly at the heart of its own galaxy, and the heart looked back as a void. So what actually happens at that edge? The event horizon is not a wall. It is a point of no return. Cross it, and every path forward, every possible direction you could move, leads deeper in. Escape would require traveling faster than light, and nothing can. Not a spaceship, not a signal, not light itself. And time bends there. Near a black hole, gravity is so violent that it stretches time itself. If you watched a clock fall toward the horizon, you would see it tick slower and slower, the light from it sliding redder and dimmer, until it seemed to freeze forever at the edge. A frozen ghost that never quite falls in. For the clock, nothing strange happens at all. It simply crosses over. Fall closer, and the difference in gravity between your head and your feet becomes monstrous. The pull stretches you, thins you, draws you out into a thread of atoms. Physicists have a name for it, half joke and half horror: spaghettification. We have actually watched this happen. When a wandering star drifts too close, the black hole tears it apart. Half the gas is flung back into space, the rest spirals inward, heating to millions of degrees. Blazing across the galaxy in a flare we can detect from Earth, a single star unmade in days. For now, our Sagittarius A star is quiet. It is not feeding much. But it has not always slept, and it will not sleep forever. When gas clouds wander too near, the monster will wake, and the center of our galaxy will blaze again. And here is the strangest twist of all. Black holes are not truly eternal. Stephen Hawking showed that they leak, a whisper of radiation escaping at the edge, so faint it is almost nothing. But given enough time, that whisper wins. Over a span of years so vast it dwarfs the current age of the universe, even Sagittarius A star will dim, shrink, and finally vanish, evaporating into the dark it came from. So the next time you find the Milky Way stretched across a night sky, remember what hides inside that gentle light. A 4 million sun monster 26,000 light years away that has held you in its grip since the day you were born, and will keep turning the galaxy long after every star you can see has died.